Elements and atomic structure. Okay, let's get back to some basics about atomic structure. So here's my wonky electron configuration diagram here. Now this little format here thing is what you may see in some textbooks. And X stands for the element. So let's say we're doing carbon. So X stands for the symbol of the element. Then we have A. Now up the top as a superscript, that is the atomic mass. Okay, so the atomic mass. And if you remember, the atomic mass is just the protons plus the neutrons. Okay. Down the bottom here, though, is the atomic number. And the atomic number is just simply the number of protons. And so remember, the elements are listed on the periodic table according to increasing number of protons. So hydrogen's 1 has 1 proton. Helium is 2, has 2 protons. Lithium is 3 protons. So carbon is number 6, so therefore it would have 6 protons. And so we go 6 down the bottom. Now up the top is its atomic mass. Now carbon has 6 protons and 6 neutrons. So that means 6 and 6 is 12, so it's going to have 12 at the top here as its atomic mass. In this type of carbon atom, because it's got 6 protons, it has to have 6 electrons. Okay, so let's just draw them in as crosses. And so we have 2 and then 4. So that's the electron configuration of carbon. Now here's the crazy thing, is that there are different forms of carbon. Okay, so out of the 100% of carbon that exists on Earth, or the 100% of carbon that your body is made up of, not all the carbon atoms are the same. I mean, they have to be 6 protons. Otherwise, if they weren't 6 protons, then it would be not carbon, right? So they all have to have 6 protons, because it's the number of protons that determines the type of element. So we have 6 protons. However, some carbon, so let's just write this here, let's just say we've got protons for P, 6. But what about neutrons? Well, if it has 6 neutrons, just like over here, then it would have 6 protons, 6 neutrons, and that would make 12. So we have a carbon 12 atom. Now, if we have 7 neutrons, then 6 and 7 is 13. And so now we have a different form of carbon called carbon 13. And if we have 8 neutrons, then we have carbon 14. And so these different forms of the carbon atom are called isotopes. Okay? And you may remember from year 9 that isotopes are radioactive. Okay, so carbon 12 is very stable, but carbon 13 and 14 are radioactive. And we can use that concept to work out the age of objects. All right, so understanding about the Iceman Ötzi, we can take some samples of his bones or tissue, and we can do a carbon analysis, and we can work out how long ago he died. So it's pretty cool stuff. So that they're called isotopes. So if we look at the atomic structure, we can put it in a general form here. And we know that the atomic mass is at the top, protons and neutrons, atomic number is down the bottom. And if you ever get questions that says work out the number of neutrons, well, if the atomic mass is protons plus neutrons and the atomic number is protons, you just take that away from that. Right? Because P plus N, take away P just gives you N. So if I had, for example, for carbon here, I've got atomic mass which is 12, okay, and then if I take away the atomic number, 6, that's saying I have 6 neutrons. That's all you do. Okay, atomic number, you take that from the atomic mass. Alright, so that's it. Pretty nice and short video. General structure of atomic mass. You can work out the number of neutrons by taking the atomic mass away from the atomic the atomic number away from the atomic mass. Okay, and that's pretty much it. We learned a bit about isotopes as well. So see you in the next video.